You now are on YouTube. It's recording. All right. All right, everybody, here we go. Quiet down, quiet down. I'm recording. All right. All right, so everybody, this is problem 6 from section 1.4. It's an even, right? I'm doing an even because there's no answers. It says a rock is thrown upward on the planet Mars with a velocity of 10 meters per second. Its height in meters t seconds later is given by y equals 10t minus 1.86t squared. And they're asking us to find the average velocity for 5 intervals, right? 1 to 2, 1 to 1.5. Here's what I want to make sure we're clear on. You can do this all in math. Guys, you can find the y values for all these x's, but it takes forever. So every time we have an average rate of change for multiple points, we're going to use f of x plus h. So we're sitting here, and everybody, all this English, they're always going to give you the formula. The physics just matches, if you guys remember physics. That's what they're matching in the words. So over here we have f of t, is what I'm going to call it. All right, let's be clear. You don't need a graph. You don't need a graph. You don't need a graph. Guys, I'm going to make a graph. Everybody, if we factor a t out, does everybody agree this was a parabola opening down? Okay, parabola opening down. If I can factor the t, I know the two zeros. So everybody, I don't need a great graph, but I can see 0 is a 0, right? I put 0 in here. Everybody, how about we just 1.86? That sucks. If this was 2, it'd be 5. 6 is a little too big. So somewhere over here at about 5.5, and I'm going to use approximate, is the other 0. So everybody, this graph's going to look like this. There's our rock. I don't know where the vertex is, right? I'd have to solve it to figure it. I don't need it. But I want to be clear. We want to be able to picture what's happening here. Everybody, I am very positive at time 1. Because 1 is in all these. Do you guys see 1 is in all the intervals?
Yes.
Guys, do you guys agree the instantaneous slope here has to be positive? It is an increasing function at 1, so it has to be a positive answer. So I already know for letter B, it's going to be 1. And most likely, maybe the 1, 2 is not positive. I think it is. I think they're all going to be positive is a guess just looking at the graph. And that's a horrible sketch, but it's good enough. Everyone, I want to plug in these values. So I'm going to go back and do this. I'm going to do f of, I'm going to call it x plus h. You could say t plus h. Does everybody agree? Guys, this gives the average rate of change. This is asking for the average velocity. And once we set it up, we can get it down to one function. So every time we have this, we go. So here I go. I'm going to plug in x plus h. It's 10 times x plus h minus 1.86 times x plus h squared minus 10x minus 1.86 x squared all over h. All right? So if I go down the screen a little, because I'm going to try to... A little further. I wish I could make the board work better. All right. So now I'm going to do a little math, right? 10x plus 60. All right, everyone, this is one of my tricks. We know this by memory. You guys all agree that x plus h is x squared plus 2xh plus h squared? So I can distribute the negative 1.86. 2 times 1.86. 2 carry the 1, 7. 3.72 xh minus 1.86 h squared minus 10x plus 1.86 x squared.
Anderson, where did you get the 60?
10 times, H. Can't even read my own handwriting. Good question. That's an H. That's not 60. Good job. I'd have caught it on the next line. All right. Everybody, what has to cancel? Everything that doesn't have an H, right? If I have a math mistake here, it should show up now. 10x, negative 10x, 1.86. Everything has a H. Awesome. So everybody, my average rate of change formula for letter A is 10 minus 3.72x. That H cancels, minus 1.86. H, do you guys agree? All right. All right, now, everybody, there's a huge, we can do one thing here. Guys, this is a graph that starts at x, right, and goes the duration of h. Guys, where does it start for all our intervals this time? Starts at 1. Guys, x is always 1. So let's put that in right now. Who's got a calculator? What's 10 minus 3.72? 6.28. Everybody. Now, I want to be crystal clear. We've got to be really careful here. I'm going to go back up to the problem. Guys, if you start at 1 and go to 2, what's the H for little Roman numeral I? What's the H for this one? From 1 to 2? 1. Guys, what's the H from 1 to 1.5? 0.5. Guys, what's the H from 1 to 1.1? 0.1. H is 0.01. And H is 0.001. Guys, all we have to do now is make a table and use this formula. All we have to do now is make a table and use this formula for these 5 H values. We don't have to find Y's, we don't have to do all the points, and we literally have the answers. All right, so if we go down the page and use it, all right, and it's Roman numeral I, triple I, I4, and 5. 1, 0.5, 0.1, 0.01, and 0.001. Guys, if you plug in, now it's just calculator time, you guys agree?
I agree.
Somebody got values or not? All right, I gotta grab my calculator then. You got one? So 6.28 minus 1.86, right? Guys, what's the units? All right, what's the units going to be while I grab my calculator? We got to think what the units are. Because guys, this started, right? So we got to read the word problem and need units on all these answers. So we got to look up the top. 6.28 times minus 1.86 times 1. So average velocity. How about 4.42? Everybody, the word problem said that it's going in meters per second. So guys, how about meters per second? 1.86 times 0.5 plus 6.28. How about 5.35 meters per second? How about 6.8 minus 0.186? 6.094 meters per second. Guys, 6.28 minus 1.86 times 0.01. What's happening? Do you guys agree that this value is becoming less and less important? The H value, this second term is almost insignificant. You guys agree? So I get 6.2614 meters per second. Last one, 1.86 times 0.01. How about 6.27814 meters per second? All right, everybody, based on the red equation, I'm not going to look at the table. Guys, if you want the instantaneous velocity, what do we want H to go to? 0. So what do you think the instantaneous velocity's got to be? Guys, how about 6.28 meters per second? And everybody, you can't find this value easily unless you make this equation. If you do the table by just doing y and x, and rise over run, you can look at the table and yeah, you might think it's getting there, right? You can look. It's going 535, 60, 626, 627. How do you know it's 628? You really don't unless you have this formula. And everybody, did we divide by 0? No, because what we do is we take the limit as h goes to 0. All right, this is section 1.4. I'm not going to lie. I did this amazingly fast. And I bet you the video is 9 minutes.
10.
10.
Almost 11.
That's almost 11. I should have taken me 9. I didn't prep anything. Guys, these are 20-minute problems, minimum. All right, you got to try a couple of them. You won't be able to watch me do this and then reproduce this on the test. All right, let's take a brain break. I'm going to get the video stopped. Hi, YouTube.